What's up, everybody? Welcome to Flux Harmonic. I apologize for the delay getting things set up today, but I had multiple technical problems and it took a moment to get everything working, but now I think we're okay. Unfortunately, we're not streaming on Twitch right now because Restream decided that it wanted to let me stream with them at about 320 KB per second, which is not enough to do a stream. So we're just going to go straight to YouTube for now. So today, we're going to continue on our game development project we started a couple streams ago, and we are going to try to write code that initializes a predefined game board for our game Crash the Stack, which is a Mahjong styled game, and possibly try to make it interactive depending on how far we get. I think that what we'll do today is a bit more straightforward than what we did last time, so we should be able to get some good results out of the stream. So I think we'll see something cool by the end. So, updates since last time. Did make a decent amount of progress fixing some issues that we found in the last stream as we tried to build the ECS that I was talking about at the beginning of the stream. There were a few things we noticed. Like, one problem was that if expressions required there to be an else expression as part of the if expression, which is not really a thing that you have to do in Lisp languages. Typically, you can just have a truth path and that's it. And otherwise it would just return nil. So I went and changed the if expression that I have in the mesh language we've been working on to allow the else expression to not be provided. Then it will just return nil if the predicate evaluates to false. Also, recursive function and let calls were not working correctly. There was a case where it seemed very strange how things were being resolved. Like it should be resolving a local variable, but it thought it was something else. So I realized that there was a problem in how we were comparing the function name of the body with the function itself for recursive calls, and found a particular issue there that I was able to fix, which is nice. Now all that stuff works correctly. And then lambdas that were being generated from let expressions were not capturing their locals. There was kind of a big problem I had toward the end of the stream where strangely, a named let that I'm using as a loop inside of a function would not be able to access the variables of the containing function. And that's because I forgot, whenever I did this let conversion to lambdas, to add the variable capturing code to create a closure. So I fixed that. Now everything there is working fine. So I'm feeling a lot better about those parts of the code now. At least, you know, we've tried to write real code with it, and we've seen how there could be problems, and I was able to go and fix them. Also, I managed to fix a number of issues with garbage collection, which caused some crashes that you didn't see on the stream, but I did see after the stream. Basically, where if I were to start the game and let it run for about 15 to 20 seconds, eventually it would crash because it would try to do a garbage collection. Everything had sort of been building up to the point where it did a garbage collection, and then there were a lot of things that got freed, a lot of memory that got freed up when it was still supposed to be in use. So some of the code that I had written recently for like record types and some of the module loading stuff was not being caught by the garbage collector correctly. So I was able to fix all that. Hey, Robert, thanks for joining. Also, thanks to Luis and to Daigo for being here as well. I forgot to mention you guys. So the garbage collector is running much more consistently and reliably now, which is great. I can let the game run for a while and it won't crash. The reason why there's things being allocated enough to cause garbage collections is because of the creation of closures whenever you have these named lets. So every time you call into a named let inside a function, it basically creates a closure to take in the local variables of the outer scope. So every time you create one of those, it has to be garbage collected at the end. I am highly considering either changing that design to not require lambda functions and closures, or providing a different looping mechanism that does not create a lambda, so that you do not incur the cost of creating new closures every time. Now, obviously, that doesn't solve the problem for named let when you really want to use it. So I might also try to add some code for caching, or let's say creating an object pool for closure objects, so that we allocate a certain number of them over time, and then we don't actually free them, we just sort of reuse them. And that might actually help a lot with the allocations. When people complain about using a garbage collected language and saying that, you know, the GC pauses cause the app to slow down, it's typically because things are being allocated so frequently that you end up incurring these GCs. But for a game and game or any code that needs to be high performance, I think you can sort of write the code in a way to minimize allocations after a certain point and sort of get into a steady state where you don't have as many allocations, and then you don't really hit a GC at that point. So that's something I'm going to experiment with at some point in the future, because I think that will actually make this language pretty fast for game development if we can, figure out the right patterns to not be allocating every single time we call a function, or I guess really often. So something we'll look into for sure later, whenever we get into a bit more of a sophisticated situation with the code. Also, I'm going to mention that we did try to get the ECS implementation going in the last stream. After the stream, I spent a little bit more time on it and did make some progress, but I realized that to do ECS the right way, or at least the modern way, the way that people think about archetypes and storing collections of components for certain types of entities and having entity queries and this kind of thing, it's a bit more complex than what we need right now to just get a game working. So I think I'm going to put a pause on that effort and maybe work on it here and there in the background so that we don't have to spend a lot of time on stream with it. I think it's going to be more interesting if we just write a game. So we're going to spend time writing actual game code without any kind of complicated or fancy engine design. We're going to just write it straightforwardly, and then later we're going to figure out some ways that we can make the design better whenever it's warranted, which is going to be better for us because it just means that we'll get to nice results faster. Okay, so today we're going to try to make this look like an actual game. So we've got basic rendering working in the engine where you can see the tiles rendering to the screen. But it's all just sort of random right now. It's sort of just like in a test state. In fact, let me show you the way it looks right now before we start messing around with it. This is just 5 tiles on the screen, sort of just in a diagonal. I set these positions myself. So right here, we define the array of tiles and we just push a bunch of tiles that we've created. But we want this to actually look like a game and have the ability to have a grid of tiles to look like a real Mahjong game where you would be clicking on tiles to match them. If you don't remember from last time, let's see, GNOME Mahjong. Let's see if I can find the screenshots of that again, images. So we're going for something basically like this, if it full screens. Okay, perfect. Whatever. So this is sort of what we're looking for. We're trying to make a grid that looks like this, where you have multiple layers of tiles. So there's like a base layer, and then layers stacked on top of that. And if you notice, the way that the tiles are laid out, certain tiles can be centered on top of other tiles, or they could be sort of at an offset. So part of the design will be to try and replicate this kind of tile layout in our own code, which shouldn't be super hard. I've written this kind of code before, so we're going to take inspiration from what I did before, but we're going to write it in Mesh in a slightly different way because I did it in a more functional style last time. This time we're going to take a more imperative style. So we're going to start from our humble beginnings here. We have a few tiles rendering on the screen. Then we're going to try to render an actual grid of tiles so that it looks like a game, and then we can start trying to implement behavior for the game, like clicking on tiles, etc. So that should be a lot of fun. So we're going to try to implement this in 2 phases. First, we need to make it possible to render game tiles in layers. So we need to have that layered approach where we could just see some tiles rendering sort of like what you see in that example. Then the second phase would be have a way to describe the game board in code so that we can actually sort of craft a game board and have it be rendered on the screen. And we want it to have a sort of slightly more convenient syntax, not doing what I'm doing here where I'm manually creating the individual tiles. We need to have a function that can take a data structure effectively and then turn that into a tile list that gets rendered. So that's what we're going to work on today. And a little bit more detail on how this is going to work in practice. The tiles on the board have their own sort of inherent coordinate system, or at least this is the way that I've thought about it. The middle of the screen, which is like the center of the middle tile, is 0, 0. So we're talking about the center position of the tile in any of these coordinates. So 0, 0 is the center position of the screen. And then there are full tile positions, which if you start at 0, 0, you can sort of move over one whole tile width. And that will be like a whole number. So like 1, 2, 3, etc. And then there can be half tile positions where, so you have the very, very center at 0, 0, but you can move it over by 0.5 to make it just move over just a little bit. So it can give you the ability to have a slightly more complex board layouts, and it's sort of inspired by what I examined by looking at this type of board layout here. So as you can see, like right here in the very center, if you can see where my mouse is moving, we have this center tile, which seems to be at 0, 0, and then we have sort of 4 tiles around it that are sort of at a 0.5 position over to the left and right. So we'll be able to replicate this exact thing with our own code. And each higher layer that's stacked on top has an inherent pixel offset so that it renders correctly and preserves this sort of perspective. So if you can see right here, we have the bottom layer of tiles, then we have this next layer up, and it's sort of rendered in a way where it seems like it's on top of the tile below, but it's just sort of shifted a little bit whenever it's rendered. So we'll try to replicate that too. I've got a couple of examples of files for describing these stacks that I call them. And let me just pull up one of them here. This is I think it replicates this specific board. So we have this old scheme file that I did in the previous incarnation of Crash the Stack. And this is basically what it looks like. It's just a list of positions. And you have some nesting for the individual layers. So like this is the first layer, the bottom layer, I believe. And then there's another sub list for the second layer. And then everything going from that point forward is like the final layers. We're gonna do something like this. Basically, we're gonna write it in our own code. I don't know if I support const pairs in this particular form, so I'll probably just do nested lists. But we'll get there. I think it's gonna be fairly straightforward to do this. We just need to go and write the code to translate those. Oh boy. So the last couple streams that I tried different music, I got copyright strikes. Not really copyright strikes, but I got copyright claimed on the stream recording. So I'm trying another playlist or something, and it's got some random stuff in there, so we're gonna have to skip music a little in the stream. Okay, so our tasks for today. We're gonna manually create a simple game board with layers in code. So we're gonna try to set up a simple game board and just get it rendering correctly. We're gonna set it up with the actual tile positions that we expect to see, and then try to render it out to the screen in the right way. And then once we get that rendering, then we're going to try to create a game board using a data specification written in lists, sort of like what I showed you right here. We're going to have something like this that we're going to use to try to create the tiles necessary to render. Then we were going to try, if we get this far, which we might get this far, we're going to try to start adding basic input handling logic. So you can try to click on a tile and it will tell you which tile it is. But I'm not sure yet how easy that's going to be because of sort of the projection matrix that we were going through. I don't know yet whether it's easy to calculate that. So we're gonna maybe give that a shot. But if we don't really get that one working, we're gonna try the next thing, which is try to set up render scaling to make the tiles scale to window size. Because as you can tell, the tiles are very small. And my aim with this game is to create something that looks more like a retro pixel art game. So we're gonna need to scale these up to look more pixely. But we need to do it with respect to what the desired rendering size is. So there's some calculations you could do to make that work, and we might try to do that a little bit later in the stream if we get some progress made on the other parts. All right, so let's get to it. First of all, we're going to try to create a simple game board with layers in code, and that does imply that we need to think about the right way to set these pixel positions. So let me get a sip of coffee and we'll get started. All right, so one thing we don't have yet is the ability to get the current window size. I'm trying to listen to this music. A little bit weird, but whatever. If we could have the window size at any given point, then we could center a tile in the middle of the window. So what we would want to do is be able to draw a tile at 0, 0. So if we draw this at 0, 0 right now, then we're just going to see it show up in the corner. See, right there at the very top left corner. But what we want is for that tile to show up in the very center of the screen. So we're going to have to do some calculations to make that happen. So make tile, we have some code here for drawing the tiles. So we would need to do the calculations here based on the tile X, tile Y. We'd probably just try to put the position of the tile in the center. We also need to render the tile centered as well, which means that when we call render or draw texture, we're going to have to tell it to draw it centered. And I don't know if I have a parameter for that yet, so we will have to add something. So something like, let's say, centered T. So for renderer draw texture, I think that's a direct function call. Renderer.c draw texture. So let's see. We want to wrap this probably with a function that can have keyword arguments. Actually, it's this one. Hey, Fikri. All right. So draw texture here. So draw texture itself probably needs to take more parameters. This is going to be the internal version of the function. And we're going to say bool is, or centered. Let's just say centered. We were doing something similar actually in Flux Compose, now that I think about it. So let me go take a look at what we did there. So in Flux Compose, we, let's see, we went to the lib, graphics. Actually, no, let's go to, source modules. There we go. Source modules, graphics, centered. Okay, so we did have something that basically let us say we wanted to render something centered or scaled. So we probably want both of those. We want scale and centering. So if I were to go into the crash stack code base, into vendor slash, not vendor, substratic slash graphics. No, was it renderer? Yeah, we've got some different naming here. We don't have a renderer module yet, so let's just copy this a little bit. Go into renderer.msc, paste this in, substratic renderer. It would be nice if natively defined functions could handle keywords directly. I probably will add that, but I just don't have it yet, so we have to do these wrapper functions for now. So we're going to define a function, renderer draw texture. And the first argument will be the texture, I believe. Or is it the renderer? Let's see. Renderer. Let me go and look at the renderer.c code here. So we pull the, let's see, the renderer first, then the texture, then X and Y. So renderer, texture, X, Y. Then we're going to have keys for scale and smoothing. No, not smoothing, centered. Okay, so that should be enough to do that. And then we're going to have renderer draw texture internal. And we're going to fix the letter here. And then we'll just basically copy those parameters through. So renderer, texture, X, Y, scale, centered. And the idea is that we'll let the caller of the function in mesh not pass in the scale and centered parameters as keywords. And then the inner function will expect all of them, and the C function itself will be able to just handle them if they show up, but otherwise it will just give defaults. So in fact, you know, I need to get actual defaults working in these keyword parameters so that this function wouldn't even have to think about the defaults. It just takes whatever gets passed in. But for now, we'll just have to deal with it this way. Okay, so we can assume that they're going to be there. So as bool, I think that I have something for that. Args 5, and then I think it's double scale as equals as number args 4. Okay, so that gives us our scale and whether it's centered or not, and we can actually pass that in here. So draw args init. We give the scale here. Is it a float or a double, I wonder? Draw args init. It's a float. Okay, so we just call that a float. And then centered as bool args 5. I think we need to say subst renderer draw args center at draw args, and then centered. That should set everything up correctly for those parameters. So we can test that out a little bit after I fix this. So we're gonna say renderer draw texture MSC. We're gonna go back up to right here. We're gonna change it to say renderer draw texture internal when we register this function into the module. Render draw texture internal. Now we go back to renderer, and everything should be right now. I think that this should work. Got my Nice little backdrop flopping again. All right, so that should be good for that. Let's try to build it and see if it works. Okay, so it's very small now, which does make sense. And I did not say centered, so now if I go here into main.msc, let's say scale is 3. How about that? Let's just try that out. And then, oh, it's centered T. Interesting. We'll take a look at that in a second. Okay, so the scale does seem to have been passed through. What about 6? I don't know. This seems pretty small. Okay. Looks terrible, but it's better. It may actually be centered, in fact. So let me turn this to nil now and see if it works. Okay, so I think it was being centered, and that's quite huge, but it actually looks kind of nice for what we're trying to do right now. But I'll just turn it back down to 4 maybe. Multiples of 2 generally are good for these kind of pixely looking things. Cool, so that looks great. Now I'll put it back to centered T. Hey, IO control, sorry. Or IOTCL, not exactly sure. Maybe we've talked about this before. Not sure how to pronounce your name. So we got that set up well. Now we need to get something for the window width and height. So if I go to window.c, and I want to get a window width and window height function going. So we're going to just copy these here, window width, window height. And we're going to make these functions now, window width, window height. And we can copy the show function to do that. So we can, let's see, as number, no, I'm trying to remember the right way to create these. Let's go to value.h. Let's see. Compiler source value.h. I just need to figure out how to make these. Number val. Okay, cool. So number val. We have the window pointer here. So what we can do is pull this. That's good. And then now that we have a subst window, we can say width, I think. Let's just fix this a little bit because it's a little messy now. All right, so we have, let's wrap that one more time, I think. Or maybe it was wrong. Let's do that. Take that one off, okay. So now we should be able to pull width off of that. And this is gonna be the width parameter or width function width. And we're gonna copy that here. Window height. We're gonna copy these two and go into window dot, well, do we need to go to window.h? We don't need to do that now. That's great. If we can stop having to put these functions in the public interface because we now register them internally, then that's great. All right, window width, window height. Those should render correctly, I think. So window width and height, I need to fix this to say height. Let me know, uh-oh. I'm having some stream stability problems, it seems. Let me know if you end up having trouble watching the stream. It might start buffering. I don't know what's going on with the internet today. It started snowing in Greece again, so who knows what that's going to cause. Okay, so let's go back to main.msc, and we can try this. We're going to say window width divided by 2. And we are going to subtract the tile position from that. But we also need to multiply tile x by the tile width. Do I have that as a variable? Okay, tile width. All right, so we're multiplying that and we're subtracting. So this should, in theory, center it, I think. Let me clean this up a little bit so it doesn't look as horrible. All right, so we're dividing window width by 2 to get the center. That gives us the center point on the window. And then we subtract the position of the tile with respect to its, or sorry, we multiply the position of the tile by its width to, oh, we probably need to divide that. No. Let's try it like this first and see how it looks, and then we'll figure out what we need to do. Because we're centering it when we render it already, so maybe it doesn't require any extra behavior. All right, so let's try that now. All right, so subst window height MSC, undeclared identifier. Okay, that makes sense. So we're gonna go into window.c. We probably need to just move this function down below all the other script functions so that they exist, since we didn't actually export those. All right, segmentation fault, cool. Since we didn't actually put those in the header, they need to be they need to exist in the source file before we try to register them. So now we saw that it crashed. Let's see what we can figure out here. If I can print f requesting width for, see which window we're requesting it for here. That would be this subst window cast of the pointer. Oh, did I pass the window in? That could be part of the problem. No, I did not. So let's do that. We got the width, oh, sorry, the window. Maybe even the window is not the right place to do this. Maybe we should ask the renderer what the size is, but we'll get to that another time. All right, so this is complaining about in window.c, I missed a semicolon right there. Now the code formatter should put everything back where it belongs. Okay, so I think that that's sort of working, but it definitely doesn't put the tile on the screen. So let's take a look at why that's happening. So we're gonna write out what the width is here. Let's just do this. And then we should see it written out from the C layer to see whether it makes sense. Okay, 1320, that does sound right. So we're getting the width. Main.msc, tile x of tile multiplied by tile width, which would be 0. So really it's just subtracting by 0, which should be fine. So window width of window divided by 2. Can we just write that out? Display. Well, I'll just copy it. It's easier that way. Let's copy. Whoa, what did I just do? We'll copy this whole expression. What? You can't yank. Okay, whatever. I upset it somehow. There we go. Let's do this and then display. We're just gonna have a new line there to break it up a little bit. Okay, so 660 is where it should be rendering. Which is right. I don't know why all of a sudden it's, you know, this is the thing where scaling is gonna bite us. Let me put this back to scaling 1.0. Okay, so that is correctly centered, this tile here. Now it's impossible to see it, but we need to fix this issue that we have in the renderer where scaling the sprite also scales its position, which is not what we want. So let me quickly try to do that again. We've hit this problem before in previous streams while working on Flux Compose. I need to solve this problem once and for all. Okay, so scale. Let's see. Is this the right one? This is inside of draw rect. We want to look at draw texture EX. So right about here is where the scale values are pulled out. Now what we're doing is translating first and then scaling, but I think that's wrong. I think we should do it the other way around. Let's see what result we get if we do this instead. No, it still doesn't show up right. Something is very strange about that. Oh, I think I did it backwards. So scale make and translate. Still not working correctly. Let me think about this for a second. There's definitely something wrong with the way that I'm approaching this. Maybe the excuse me, the view matrix is the right way to approach it. We need to translate it some other way, but let's do this really quickly and see what happens. So, do I actually use the view matrix? Yeah. All right, so Glm Translate. Oh, I'm doing a multiplication here myself too, which is totally wrong. I don't know why I did that. Let's try this first. Let's go back here and take this out. It shouldn't be here. Still not fixed. What if we take the scale out for a second? Just go directly on the translate. Oops. Yeah, we're there. Okay. All right, and that isn't even working correctly, which is very strange. All right, let's think about this. If we have to do it just, you know, at the original size of the tile, then that's fine. I don't really want to have to do that, but we'll do whatever we have to. All right, so model vec3 x, y. Let's print it out. So x, f, y, f, x, y. Okay. So 660, yeah, that's correct. Well, let's also go into main.msc and do the same thing for the y side. All right, so here is window height. And this is tile y multiplied by tile width, or height, sorry. I'll get rid of this one right here. And then see what the output looks like. And it seems to update. Yeah, that's good. So, oh, let me also double check, make sure that we don't see anything rendering. Yes, nothing's rendering right now. It's kind of interesting because you would think that you would at least see the thing drawn in the right location on the screen. So we're making a translation of the model position. Oh, that's the right thing. Nah. Yeah, so because we're doing this in a weird way, I think it's biting me. Okay, let me think about this for a moment. Adjust position if texture shouldn't be draw centered. So texture width, texture height. I might need to change my whole approach here and have vertices that are respective to the actual pixel size and not this sort of, you know, hacky approach that I'm taking. Because I think this is the problem I'm having. I have to scale the sizes. Let's see, arg scale x, arg scale y. But we also have to scale with respect to the texture width and height. So x plus texture width divided by 2f. That's for centering. That's fine. But there's also another scale factor being brought in for the width and height of the texture. And that's what we're doing right there. Okay, so that actually makes sense. So we have to have the scale in place. So if I were to take this out and I don't factor this in, still doesn't draw. Let's get that out of there too. So texture width times scale x, texture height times scale y. And they're both 1. So at this point it should be drawing, if I'm not mistaken. But let's go backwards. Yeah, I think that's the core problem. There's just something weird about how I'm doing the scaling operation here to make the texture render the right size. So let's think about this for a second. What I've done is I've allocated a vertex array. And I'm just sort of holding on to it. I'm trying to think if there's a way to avoid. Let's see. OpenGL reuse vertex array. Is it array or buffer? Yeah, it's not exactly what I'm asking. Yes, can I reuse the same vertex data with different colors? Okay, sure, you can do that. But OpenGL 1 vertex buffer to draw 2D sprites. I don't know. Let's see. I'm guessing this is going to tell me that to do it the right size. Oh. Interesting. Okay, this is good. So it uses 1 and 0, which is not the centered approach that I'm using currently, which may be better, actually. What I'm doing is a little bit stupid. So how does it do its translations then? First of all, it sets a model matrix to identity, translates to the position. All right, we're not listening to Christmas music right now. Come on now. And then it does the, what is this? Translate to, okay. So it first translates to the position, then translates with respect to half of the size of a sprite. Then it does any rotation if necessary. Then it does another, okay, so it sets the center point of the sprite before rotating so that it rotates at the center. Then it moves it back to where it was before. And then it does the scaling. Cool. So that's a good model to follow. Scale it to size. So if we don't care about the rotation part right now, we just ignore this, then what they do is they translate first to the position, to the desired position, and then they scale it to the size, which, I mean, that's what I'm doing, right? Okay, how about this? Let's try changing this to 1.0. So this needs to be 0, I think. Yeah, 0. It's a little bit different ordering of vertices. I'll have to be careful about that. So top right, in my case, would be 0 and 1. I mean, this should work the way that I'm doing it, I think. Here, let me just think about this for a second. Top right. So first, maybe that's a mistake I'm making, is I'm scaling it. So they scale first. Sorry, they translate first. They set the position to... So let's check out GLM Translate Make. I'm pretty sure that sets up the matrix first and then does the translation. Transform 1, transform 2. Can you tell me what they do? Click. New translate transform matrix by V vector. Matrix M. Translate vector X, Y, Z. Okay, which is what we're doing, X and Y. That should be enough. And also, let's forget about that for a moment. Translating should be enough. We'll also go back into main.msc. We're going to take out this little snippet of code right here because we don't need that anymore. We've already verified that it's doing the right thing. And then render.c. This is not what I intended to spend my time on today, but if we can get it fixed, then it's going to be much better compared to what we were doing before. Okay, so let me just take out a lot of stuff here. I want to get rid of any distractions, anything that should make it do the wrong thing. Okay, so yeah, that we're still missing the last step, which is scaling it up based on the size, which this would take care of. So the model, we're moving to position, then we're scaling it based on texture width and texture height. I'll take the scale, well, let me just comment this out really quickly. Take the scale X, scale Y out first. And in theory, it should put it in the right position on screen. Oh, okay, so it did that time. So then, here, look, what if I just do this again? Do another separate scale, scale X. I really don't want to do it this way, but if it makes it work, then all the more better. Okay, so it did, oh, yeah, okay, I didn't load up the scale parameters. Oh, okay, so now it works. So I wonder why it didn't work before. Scale X. So let's do it at the same time. Maybe doing this kind of scaling, what I'm doing right now, is the wrong thing in terms of the math. Okay. Why did that not work before? I swear to God, we did exactly the same thing. Okay, so at least it seems to be putting things in the right place. Great, fantastic. And it's centering on the screen. Awesome. We didn't waste a whole lot of time on that. I'm very happy. Okay, let's keep moving. So now what we want to do is try to get a set of tiles rendering the way that we expect them to. So let's say we're going to just duplicate this. We're going to say 1. Actually, -1. Let's try -1 and 0. So we're going to make a line. 2, 3. And let's see what that looks like. Oh, unexpected token kind. What did that break? Huh. Interesting. Okay, we're going to go back and... Oh, the negative? Did I forget to put negatives? Oh, crap. Okay, so that's one thing that the language doesn't have yet. Oh, can I even do this? Here, -1. Did I make that work at least? Holy crap. All right. So I did not put negation in for numbers, which is sad. Cool. All right, let's think about this then. Can I quickly add this to the language? We're going to see how good I am at adding language features now. So let's go into the scanner, which is the tokenizer effectively. Number. Okay, so while scanner is digit, scanner read number. All right, so we start off here. Mesh scanner next token. Now, make sure this isn't the start of a symbol. Yeah, I've sort of left a note here for myself at some point in the past. So in the case of a minus, we need to see if the next thing after that is a digit, and then we can treat that as a number. And do I have, let's see, scanner make token, make number, read number. Okay, so is digit, read number. Next care. Okay, you could peek ahead. All right. Scanner peek. I haven't actually had to mess with this code in a while because it just works. So now I have to remember exactly how I was doing things before. All right, so scanner peek. seems to only take a single parameter, just the scanner. We can look at the next token. Fine. Peek next. Okay, peek next is what we'll probably want. So in the minus case, what we can do is peek next. Hey, gun. Scanner, whoops, peek next. Scanner. So if is digit, scanner is digit, scanner is digit. So hopefully this will work. This should be just enough to get us out of the problem. Okay, so we got that. And scanner read number. So we're basically saying, all right, if it's a minus, then let's check and see if the next number is the next letter after that's a digit, and then if it is, try to read it as a number. Otherwise, just make a minus token. All right, so scanner read number. So while scanner is digit, check if the first character is a minus. So scanner, what were we using for that before? Peek. Next care, read number. All right, so scanner next care. So that's what we'll do. So bool is negative, or just to say negative. How about that? Negative equals scanner peek scanner. And this returns a character, I'm guessing. Equals minus. How about that? Scanner peek. Yeah, returns a character. So we're just checking to see if it's negative. Then we should also add that character. We need to false. Let's add an actual if check. We don't want to read the character yet because we don't want to consume it if we're not sure. So if it is a negative, then we're going to go to the next character, but first we're going to say negative is true. Okay, so negative is false, scanner peek. If it's negative, the negative is true. Printf found a negative number. Just to see. And then we're going to read all the next characters until we decide that it's not a number anymore. Then we're going to make a token for the number. So let's see what we get from that. Still unexpected token type. Oh, it doesn't even cross its mind. Let me check what I did here. So there's -1. I have scanner test, don't I? Let's see. Compiler test test scanner. So finds listened. Let's see, finds literals. All right. About -1. T nil -1 2.23. Okay. And then yeah, we're not checking the values. We're just making sure that they show up the right way. So number, then string. And then if I go into vterm here, into the compiler folder and run tests, 2 failed. All right, so expected time kind token kind number got 16. Now, why did that logic fail? Let's go right down here. Printf checking if number. Next is number. Scanner is digit. Scanner peek next. Maybe I should actually check the character that's in there just to make sure we're not losing our mind. Because maybe I have the wrong logic here. All right. We'll run the test now. Checking if number slash. Oh, maybe it's I'm looking one character too far. How about scanner peak? Doesn't feel right. But maybe I already did that. Did I consume the character? I did consume a character. That makes sense. Okay. So in that case, scanner peak, scanner read number. In this case, I think that's going to be fine. Here, let's try that. Still says 2 failed. All right, checking if number next is number. Great. So we made some progress here. So found a negative number. That one doesn't think so. Let me go back to right here. So scanner peak scanner. I think I need to pass a Boolean in here to say that we already know that it's going to be negative. So scanner read number. Does it show up anywhere else? Shows up here, shows up here. We're going to say false there. We're going to say true here. Maybe it's not the best design, but, you know, it'll get us out of the jam. Negative, or is negative. How about that? Since we're passing it as a parameter. Okay, so we don't need this anymore. Okay, so I think that it should be okay. Let's go down again and just make sure that I'm passing things correctly. Try this again. Still 2 failed. Check if number next is number. Okay, so the next thing we need to look into. Oh, I'm not doing anything special. If it is negative, I don't know if it matters. Next care. Okay, so we finally get to make token. It's all, oh, okay. Still 16? That doesn't make any sense. What is the, let's see, scanner.h 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so that's 16. I think it's minus. But it shouldn't be minus. Unless, oh, okay. That's the mistake. Return scanner read number. Okay. All right, so I think that's working now. We can get negative numbers out. At least it tokenizes them correctly. I don't know if it's going to handle them correctly in practice. In fact, we don't even need this is negative. Because I think this, the tokenizers are going to pick up any of the characters that have been scanned before we say to make a token out of it. So false, let's get rid of that. True, let's get rid of that. Run it one more time. That other test failure is something new that showed up today. I'll look into it at another point. Okay, so what we can do is run the main code again and see if now all of a sudden we have negative numbers working. So back to main, back to compilation buffer, run it again. Okay, so that does seem to be working. I think that we've got a little bit of offset here. Not exactly as much as I expected, but that's a starting point. Okay, so main, oh, and also I think the scale that we're using needs to be factored into the tile size. So how about this? Maybe we can say define screen scale is 4.0. Then we also need to say that the tile width is going to be screen scale multiplied by the tile width. Same thing for height. And then that should give us correct calculations, I think. Correct, yep. So this is going in the positive direction. I don't think that's what I wanted, is it? That's negative. It should be going the other way. Unless I'm saying plus here, maybe. Okay, that seems to be going in the direction I would expect it to. Now, we're going to have to deal with the rendering order to make sure that, in fact, I think I just need to add them in the correct order to make them render correctly. So let's do this. We need to go negative to positive. Wow, still not rendering in the correct order. So we put the -1 tile first. No, I think it's the opposite way, right? Should be... want to render right to left. Still, it's kind of weird that it's... Oh, you know what? I think this is correct. It's just not... There's too much gap between them. They need to be closer together by 1 or 2 pixels. Hey, Porv. Interesting. Why is there a gap like that? Tile X, tile width. That's correct. Maybe it needs to be like a kind of a minus. Well, that shouldn't need that. Whatever. We'll get to that in a moment. So let's accomplish our original goal after we sort of had to waste time due to things, and get an actual basic board rendering. Okay, so that's a few tiles. Maybe what we want to do is start at here. Let's take a look at this screenshot one more time. That one? No, it was right there. Yeah. So we want, maybe if we want like a square like this, just get it like a basic square going. So we need 4 tiles, and I think they need to be offset by half. So it needs to be -0.5, -1.5. And then we need to also have 0.5 and 1.5. Let's see what that looks like. Okay, so that seems correct based on what I would expect to see. Also, we need a few more rows of these, so we can have the same setup. This needs to be 0.5. This needs to be, all of these need to be 0.5, really. We're going to copy those. And we can say 1.5, 1.5, 1.5, 1.5. Let's see what that looks like. Okay, we've got a couple of rows now. I think maybe they're in the wrong order, though, to be rendered correctly. That seems to be better. Okay. Uh-oh, I've deleted the compilation buffer. Great. Compile. Okay, so we got 2 rows. We need 2 above also. So we're going to do the negative rows now. We're going to say negative 0.5 on these. See, this is why I don't want to write the code like this, because it just looks terrible. And then we'll copy again, and we'll do 1.5. I think we could just do this little optimization here. All right. Okay, so we got a nice little square here, which is a good starting point, I think. Oh. And we got a nice little segmentation fault that I did not expect to see. I wonder if that's a... let's see. Does it happen again if I just let it sit there for a minute? Uh-oh. Some more bugs. Not good. Okay, so let's just keep moving for a moment and we'll deal with that later. So we're not thinking about layers yet. So we need to actually add a layer field to the tile to say what layer it's on. And for all of these, we're going to want to say that it's on layer 0. Layer 0. So I'm just going to go and just paste this in on all these guys. Which is not, you know, my idea of fun, but here we are. All right, so let's take a look at this example again. So the next layer is actually going to be in the same coordinate space with the sort of negative 0.5s, etc. So we can copy and paste this thing. and put it down here. We're going to change all of these layer elements to 1, but we're going to delete some of them because we don't need them anymore. So let's just do it like this. All right. And then any of the negative 1.5s or 1.5s we're going to get rid of. So we don't need any 1.5s. We just need the ones that have 0.5 and 0.5 together. I'm pretty sure. Okay, so that has 0.5, that has 1.5s, boom. So that should be enough. Let's render that out. And it's rendering right on top of what's already there. You can't see it, so we're gonna have to add some offset calculations. So for the layer of the tile, we're gonna have to have an offset. Offset would be, is it only on X or is it both X and Y? I think it must be X and Y. And I had that encoded into the old code base. I think in, let's see, let's go back a little bit. I want to keep that tab open. So in source/crash/stack offset layer offset X. Okay, so I had two constants for this, I think. Layer offset X and layer offset Y. Layer offset. Where did I define those? Interesting. Let me see if I can search for that in the code. Layer offset X. I'm probably setting it somewhere where I have a handle on the... Oh, is it in tile.scm? Layer offset. Okay, 3 and -3. Okay, so I'm probably gonna have to multiply that by the scale. So let's try this. We'll actually put this up here. Define layer offset X. Oh, we still need that, but we'll figure it out. Okay, so layer offset X is 3. Is that right? 3 for X. Times screen scale. Actually, let's just go screen scale here. Maybe we'll move this also to be toward the end, just to make it a little more consistent. So like that. And also like this. Okay. So 3 times screen scale, and then we're going to clone this, and we will change this to Y, and we're going to make this -3 because that's what the old code dictated. I think this should be correct. So we'll find out in just a moment whether it's going to look right or not. So for each layer, we're going to want to have an offset. Offset X is... Yeah, it's nice to do this if we have... I don't want to have to multiply this every single frame. That's a lot of multiplications. It'd be nice if we could do it row by row, but we can't really do that at the moment. I will say optimizations for later. Offset X is tile layer tile times the layer offset X. Okay. Same thing for Y. Offset Y. Tile layer offset Y. So we're also going to add that in to this here. Well, I guess I could have just put it in here directly. Offset X without having to set up a local, just to keep things faster, I think. Get rid of this offset X, that's wrong anyway. Okay. And same right there. I'm going to paste that in and then get rid of these two bindings. All right, so now we should have the ability to see an offset. Uh-oh. So now, let's see. Only functions can be called tile layer. Should be correct. Tile layer tile. We have layer here as a field. It says line 37. Line 37. That's not a real line. Okay. Layer offset X, layer offset Y. Let's just comment those out for a second and see if that helps it a little bit. Okay, and then it's going to crash immediately. Yep. So tile layer of tile should have given us the layer number. I wonder if it's nil. Shouldn't be nil because we just put them in. Layer 0, layer 1. That's very interesting. Maybe we need to take a look at what is compiled out to because it seems confused. All right, we're going to go into the compiler, compiler.c. We're going to turn on the debug printing for contents of all of this. Tile layer, so it's reading a global, which is correct. So multiply tile layer read local, which tile should be the local. Then call it. Okay, so we'll turn this off or go into the VM perhaps and see what it sees when it gets to that point in the code. All right. Reporting some spam here. Okay. So, okay, so this is the 1, 2, 3, 4. 4. That doesn't seem right. Scale centered T. Where is that at? We are in main.msc. I'm looking at the results here. So the pointer would be the renderer and then the tile sprite. Then we have 4 numbers, which shouldn't be the case because we've only got, I forgot. My math operations do not support more than 2 operands. Okay, so that explains why we got problems here. Another little fix I'm gonna have to make at some point. Fantastic. All right, so we'll put this here. Maybe that's enough. How about that? A little bit ugly, but we'll go with it for now. And then put both of those inside of that. And then we'll paste this guy in, and then we'll go clean those up. All right, let's see if this nested approach works. Yeah, okay. It seems to be working, so let me kill this. If I can do it without killing the entire stream. Yeah, kill the app, please. Thank you. All right, so now we're gonna go into vm.c. We're gonna turn off the debugging line so we don't get all that spew output. Okay, so that looks pretty good as long as it was able to stay up. Now we can do the final little piece and put in the center tile on layer number 2. So I'll grab one more little thing here, and then we're gonna put it at 0, 0. 0, 0, and then layer number 2. So this is layer number 2. This is top layer, and we should be able to just see it immediately. Yep, so it's right there in the center, which is great. So we want to render from right to left, top to bottom. Okay, so that seems to be what we're doing here, top to bottom. Okay. All right, so let's figure out why this is crashing, because we can't really do much if it's crashing repeatedly. So there must be some GC issues going on again. Let's try to debug. We're gonna have to pull back in our good friend address sanitizer to see what's happening. Go back in the compiler, turn it back on its build script 2. And then we'll go into vterm. We'll delete the files for both of those folders, the compiled output, so we can sort of clean it and start again. There we go, let's do that. Go back into compilation. Now let's see what we got. All right, so we're trying to push something. I wonder if we actually exceeded the size of the value stack. That would be funny. All right, so line number 26, vm.c. So let's go to vm.c, line number 967. This is for read local. I wonder if we're just like dropping tons and tons of locals onto the value stack. Yeah, okay, maybe we need to go back and get the VM output back in again so we can take a look at the value stack as it gets to that point. It's going to take a little while probably for it to run and to hit that crash. So we're just going to have to let it spin for a second and do its thing. Yeah, it's spending so much time writing to the console while doing this that it doesn't even get to render the screen, I think. The stream's getting a little choppy. That's okay. I hope it works. All right, I don't know if this is going to take way too long. In fact, I don't want it to kill Emacs either by having a super huge buffer, so I'm just going to kill it. But while we're here, we can take a little look at what's in the value stack. I mean, that's good enough. So we got a lot of extra stuff in here that we don't want. I think that must be what happened. I eventually just exhausted the size of the value stack. So what am I putting in here that I could get rid of? Texture load, that some of these things are hanging around, they need to go away, but the things that are important is in this renderer draw texture call, and then renderer. So it's looping, it's adding this stuff and never popping it off of the value stack. Over and over and over again. And I wonder why. Let's take a look at the code and see if we can determine where it's going wrong. Main.msc. This let. So it should be a tail call because we're at the very end of the let inside of the if. Okay, let's verify that. I want to make sure that this is actually a tail call. The fact that it's a tail call doesn't necessarily mean that we won't be spewing values everywhere, but we'll go back and turn off the trace execution. In fact, I will grab a little snippet of this so we can keep an eye on what things are there over time. Yeah, this is super tall stack. Okay, so it was 149 before. 148. So it's growing by one item every time somehow. 147. I wonder if it's all the same stuff in there. 69110. And every time it adds another something to the end. It's like it's leaking individual values or something. So it's the same function. And then the fn render 420, okay. And the pointers all have the same values. I wonder if the function call inside there isn't actually popping things off, or if it's the let. Who knows? It's one of those things for sure. Okay, we're gonna go into the scratch buffer and paste in what we have here just to sort of take a look at it later when we need to. And let's see, what can we do next? Yeah, let's take a look at the compiled output and see if there's anything obvious in there, like something's not popping or anything like that. Okay, so we'll go ahead and kill the program and take a look at the disassembly of the code that we compiled. So go all the way back up. In fact, render draw draw, if I can type. Renderer draw texture. Define global, read global. Okay, so we were reading the global here for renderer draw texture. Read global renderer, read global tile sprite, tile layer. Okay. Tile layer. Okay, yeah, that's right. That's a function. And we're going to check if it's a tail call. Is there any tail? Okay, there's a few tail calls. So they're calling tile X, calling tile layer, calling window width and height. Oh yeah, you know what? I should be caching those so that I don't have to do a million calls on those. So we can try that real quick. It's not going to help, but you know, it can make things a little bit faster. In the let, that's still each one. It would be nice to grab it outside too, but we'll not over optimize just yet. When width, I don't want to overshadow. Is window width, window. When height. Whoa, what did I just do? When height, and then window height. Divided by 2 also should just be, how about this, when, jeez, come on now. Lispy's biting me. Center X, when center Y. Divided by 2. Divided by 2. All right, and then this can go away, and this can be when center X. I don't think it's actually helping, but whatever. When center Y. It would need to be in the outer scope, but let's not complicate things at the moment. Okay. Tile layer, tile offset X and Y. Yeah, we should cache some of these things. Okay, still crashing. Not a surprise. So, all the make tile calls, we don't want that. Tile layer. Okay, so tile layer, layer offset Y, it's all that stuff. And eventually we get down here and call the renderer draw texture, I think. Tail call. Must be that one. So there's an add. There's 2 adds and all of the other stuff. Where's the scale and centered? Okay, scale and centered are here. Oh, so this may be the call for the whole thing for renderer draw texture, but that's fine though. I mean, and it probably isn't a tail call because the next thing after that is this render. But it's not going recursive on its own, so it's not taking up stack space, but it is somehow taking up value space. So I wonder, renderer draw, ooh. The thought that just occurred to me is that when calling native functions, maybe I'm not popping the arguments off, which would be a big problem. So VM, call native, call value, okay. I thought I had added something for that. Okay, so pop off all the arguments and the function itself. That's when calling a native function. Arg count +1. Interesting. Function pointer, arg count, VM stack top minus arg count. Just fix this little typo while I'm sitting here. So that should be right. We need to have the ability to look at that when executing, though. Okay. Maybe I can turn the VM output back on and try to look for an execution of that call. because I would like to see what it looks like. All right, so renderer, so OP call. How about that OP call? And we know it's a call. And I can see exactly where it's at on the top of the value stack as I'm scanning through this. Oh, okay, so we didn't even make it there yet, it seems. No, it's right here, okay. So we're doing an OP call. We have scale centered T at the very end. We go all the way back to the renderer draw texture. So if I look after the call, then the value stack, which, what was the number there? So this is 54. That's 54 values deep. Now it's 52. Oh. Interesting. So we can see here that it did something wrong. It actually tried to return T when it needed to eat some more stuff. I wonder, I think what's happening is I didn't update VM call. Where is it? There's somewhere where I pop all the arguments off. Is it in the actual OP call? No. VM call value. Call value. Okay, let's just go back to that really quick. Okay, if it's a closure, you call it. So we're doing a manual stack pop here. With normal calls, am I just not popping? Arg count. Reset to the top of the value stack to shrink it back to where it was before. Boom. Okay, so wait, hold on. That's only for tail calls. Stack top. Stack top. I'm messing with stack top. VM call. We got stack top there. Stack top is keyword start. That's fine. That's in tail call. So are we just not popping the parameters to functions off? That seems wrong. Oh, you know what? I think that comes from resetting the call frame. So OP return. Frame count 0. Push the value back on so it can be read by the REPL. Stack pop. And then we reset intermediate stack values on return. Well, that's sort of the problem. I think that's what I'm missing. So I'm not removing the values that were there on the stack. And I think that's why we're ending up with a stack that gets too deep. Okay, so VM stack top equals frame slot. So this is after we've set the frame back? No, it's right here. Slots equals arg start minus 1. And arg start is, okay, so that is the right location. So if we go back here, then I think if this, no, this is right. I think that should be right. Let's try this out. Seems to be getting a little bit deeper, but maybe not quite as deep. Sort of. Yeah, it's leaking a little bit, but not as much as it was. So maybe that's an improvement. Okay. So to do. This needs more adjustment. So this is a pop. I think we should be doing these things first. Or pop the closure before restoring results. Yeah, I need to think about how this works, but maybe, well, it's gonna be a problem anyway. I'm gonna have to figure this out. So it's got 3 items left. Why would it have 3 items left? Let's think about that for a minute. So, is it actually 3? Yeah. It's function render, function render, function render, function render. So it's got the, what I don't even know what the 1 is. Then 640. 1, 2, 3, 4. No idea where that's coming from. Slots -1. Okay, this I'm just doing some black magic here now. Let's see if it crashes. -3 or -2. We don't want that function just sitting around in the stack. Okay, so that causes a problem. I think we consume too many things up the stack. And then we got another pop here. Popping the closure before restoring the result, which is basically what I'm trying to do. I'm trying to get that closure off and then leave the value there. So maybe, is that it? It's still growing though. All right, so 28, 29. It's growing by 1 every time. It's not getting that closure up stack, it seems. Mesh VM stack pop, stack push. And what am I doing here? I'm popping that. We're not out of call frames. We're not going to do that whole thing. Okay, well, how about this? Let's turn the VM debugging off and see how long it runs before it crashes and burns now. Oh, it already failed. Come on now. Value sec has been popped below initial address. Okay, I think that was something I was dealing with before. So stack top equals frame. Excuse me. Let's try this one. Just take the -1 out entirely. Wow, still that? So any kind of manipulation here is causing issues. So frame, do we have anything in there that would be helpful? OP return. So we hold on to the function result in theory. What does close up values do? Does it push anything? Move the result value into the locals spot. This seems wrong. Close up values. Close up values. Grab the next value, which should be the first local. No, I don't think so. I think that is a wrong assumption. Okay, even that's wrong. Okay, so I'm looking at the wrong thing. Close up values. So that's just doing the while loop. That's fine. Okay, so frame count minus minus. VM stack pop. So we've popped the result value off already. Then we're popping the closure, or at least we assume we're popping the closure, but we still have all the other function arguments on the stack. So the question is, who's responsible for doing this? I think it's this function right here. Because the original place where we call it from can't do it because we're adding a new thing to the call stack. So this is the location we have access to. But I don't think we know how many arguments were passed to this function. So the function only knows how many arguments it expects. I guess the call frame, we could store that information in the call frame. So let's look at vm.h, and at the call frame. Okay, so the slots, the closure, the instruction pointer. We could do that. So what if we do this? Int total arg count. So in the call frame, when we create it up here, call frame. So for the tail call, we're gonna leave it alone. But for this frame, total arg count, we can say, where is it? We did a calculation for this somewhere up here. So this whole thing here, we're gonna take this. I should probably store this in a variable, but okay, so put it here. Now, in OP return, let's just write that out. I'm just curious to see. Yeah, we don't want trace execution. We just want to see when we're about to get out of this frame. Right here, printf. We haven't set frame again. Current frame needs to pop number of args. And then frame total arg count. Is that right? Total arg count. Let's give that a shot, see what it does. I took out that code from before. What's the problem? Huh? This is completely different now. Can I just get rid of that? What the hell is happening? Caused by a read memory access. Let me check. What I might have done wrong. Yeah, nothing else changed. That is so strange. Oh, I changed the header. That's why. Okay, let me go back into vterm. Delete those. Recompile. That's what the problem is for sure. That's what I get for building things myself. Okay, so back in vm.c, we're gonna put this back where it was. Current frame needs to pop some number of args. 383838. The 8 one there seems like the right one. So there's one with 8 here. That must be that render call. All right, so what do we do with that information then? Can we say vm stack top? So we've already popped the result off. The result would have been added in addition to minus equal frame total arg count. This is going to be horrible. Let's see. Yeah. Immediate problems. Value stack has been popped below initial address. So we have 3 arguments. This is coming back from a call frame. How about this? Printf result value is... Let's just do a little spelunking. Result value is printf new line. We just want to throw some space in there. Mesh value print value. Okay. Is that enough to even get a look at anything? Result value is nil. That doesn't tell us anything really. Result frame needs to pop 3 args. Let's not do the 3 args, but we can try to write them out. How about that? So right up here, for int I equals 0, I is less than frame total arg count I plus plus. Now we want to do should pop. And then we're going to peek at the value, VM stack peek. And we're going to say frame total arg count minus I think. That should give us a readout on what things are on the stack. All right, too few arguments. That makes sense. I need to pass in the VM also. Why is it? Oh, yeah. Okay, that makes sense. Okay, cool. So at least we get a better view now. Should pop. Okay, I need to also, oh, result value. Result value is, okay. So result value is cool. Should pop. No, that's wrong. Render draw texture. Is that all? Pointer 738. I don't think so. That doesn't seem right. Result value is nil. Should pop. Can I see what the function name is of S is? And that's going to be frame closure function name. Frame. Yeah, this is great. Frame closure function name cares or no name. Whoops. So fix that one real quick. All right. Result value of render draw texture is T. Yeah, that's not right. That's too far back. Render draw texture. I must be popping some other stuff. Am I popping the keywords off the stack already? Render draw texture. Yeah, that must be happening. So VM call. Let's check this real fast because I'm skeptical now. Do we pop anything? No, that's not the one. So stack top is keyword start. Did we ever put that back? Ah, I didn't restore the position of stack top after doing this. So hold on. That's one problem because we don't have a consistent view of things. Okay, so value star. What am I? Okay. Value star prev stack top equals VM stack top. Yeah, there's no way we could keep track of this otherwise. All right, so reset the top of the stack to the location of the first keyword argument. Because we are using keyword arguments, this makes things more inconsistent. All right, so that is the check. And here, VM stack top equals, is that right? Prev stack top. We're gonna find out real fast. Here we go. Okay, so I'll kill that. Now, result of render draw texture. Okay, now we see the texture function. We see the 2 pointers. We only see one of those, but maybe that's just an offset problem. Unless it popped the, well, there's no scale there. Should pop T. This is out of order. 4 is a scale. Okay, yeah. Hold on. Huh. Okay, why is that out of order? Did I mess with it? So, okay, let me explain what I'm doing right now, because maybe it's hard to follow. I think I'm improperly managing the stack of values while executing the code. And I'm trying to see if adding keyword arguments to a function call is part of that problem. And it seems that it is, but now it also seems like the values are out of order. So I'm trying to figure out why that is the case all of a sudden. So we start off, prev stack top is where stack top is. Did we push anything to the stack before we did anything here? All right, so we haven't pushed anything yet. We push things here. Push the value on the stack. Do we pop that off? Wait, what? Oh. Push the keyword default values on so they line up with the local variables we've defined. Skip to the next keyword if the previous had a match. Apply default value of keyword argument. If no value was provided, choose nil. Wait, hold on. This doesn't seem to be the right code path. What is this? VM call. So we're trying to match up the keywords that were presented by the user to the ones that are possible for the function. We're trying to put them in order. So to the location of the first keyword. Okay, maybe that is right, actually. So we put it to where the value of the first keyword argument is. Oh, you know what? Yes. Okay, so I need to adjust the way that I'm thinking about this. It's not times 2. It's just keyword count because the total argument count is plain argument count plus number of keyword arguments, because we've removed the keywords from the list and left either the specified value or the default. All right, so that's an important little piece of information right there. So I'm going to go back and take out this thing that I did right there. And also this one right here. And now let's take a look at what the values are when we do that. I think we're getting closer. Okay, so results of render draw texture. Okay, render draw texture, pointer, 2 numbers. Now we're missing. Yeah, so something else got popped prematurely there. Oh. I think I know what's going on here. Okay, so back to OP return. So we've popped the value off the stack here. But if we take that off before we do this should pop, well, we still need to do that. Hold on. Result of S is T, which no, that's not right, because that's the value for centered. There should be another result on there. Something else is wrong. Let's look at the disassembly of renderer draw texture. Need to find out what's going on with that one. We don't have a whole lot more time here, so I'm going to just try to speed through this really quickly. All right, so renderer draw texture. Where is that function definition? Read global closure. Define global export symbol. Okay, it's right here. What is it? 2AO. There it is. Is that not right? Tail call return. Oh, it's tail calling the native function. That's sweet. What? Okay, so what does that function return? That, oh, did I not return anything from that function? That could be a problem. Where am I looking at? I'm looking at renderer.c. And I think I'm returning tval. Okay, so that is helpful, slightly. Draw texture, returns tval. All right, so when I return tval, let's look at our output one more time. Result of render draw texture is t. That could be legitimate. Should pop. It only gets down to the scale, which doesn't make sense because in main, I'm passing center t also, so something's getting lost. Is renderer.msc. Centered is the name of a key. So where's that going? It's disappearing somewhere. Am I popping something where I shouldn't be? VM call. Pop. Whoops. Pop. That's not where it happens. All right. Total arg count. Arg count plus keyword count. That's fine. Slots arg start -1. That's also fine. Because this does seem to be the right starting point. Arg count plus keyword count. Is there any way that could be part of the problem? So I know how many args there should be. So if I go to OP return, okay, should pop D. I put I in there. I is, let's see, total arg count. Let's do this. I just want to have this be right here. No, wrong. Frame total arg count. Okay. Whoa, what just happened? Whoa, whoa, whoa. That totally ate everything. Low frame total arg count. All right. So is D. That's all fine. Let's go. Kill it. Okay. Result value of render is 3. So it says total arg count is 3? No way. That's for render. Result value of renderer draw texture is 6. Okay, so would it be 6 arguments? Let's check out render.msc. 1, 2, 3, 4, 5, 6. Okay, that's right. 6 arguments. 6 minus 0 is 6. Huh. So something's missing. Calling the native function native. Pop off all the arguments and the function itself. So it's popping off its own arguments. Arg count +1. Oh, let's see what we're popping here for the native calls, because that might be a problem also. Printf popping native arg mesh VM stack peak VM stack peak VM I, and we're gonna just say mesh value print, and then put that right there, and then printf /n. All right, let's check this out. Popping native arg. All right, so popping native arg. Actually, let's go to result renderer. Wait, popping native arg. Let's also write out printf about to pop native args for. Do we have the name of the function pointer? And func pointer. I don't know if I'm assigning a name to this as native func. Yeah, probably not. All right, well, let's just keep that here like that. Okay. And I missed a semicolon. About to pop native args. All right, let's find a result renderer. Renderer right here, right? Let's check that one. Okay. About to pop native args. I think that's at the place where we want to see it. Yeah, that seems like it's popping things that it shouldn't be. Pointer native function. Yeah, where is all this coming from? Arg count +1. How many arguments? Arg count. Okay, so there's 6 arguments, which does make sense, but this does not seem to be the one I would. Oh, I'm using pop here. Ooh, that's yeah. Okay, so peak 1. That's part of the reason why it doesn't look right. Okay, now just check it one more time. We're almost done here. Popping native arg 4. There should be a T there, which is not there. Popping native arg. And then a T from a previous call. So I think, oh, it's supposed to be, okay. That's my mistake. Bad offset. All right, so here we go. I think this is probably going to give me the right thing that I should be expecting. Yeah, okay, so T for X and Y, the 2 pointers, and the native function itself. So we would pop all of those off before returning. And we've already stored the result to push. So we can say pushing native result. Which should be a T. Right. Let's run that again. And then check the result. Oops. Result R. Result val renderer. Okay. There we go. Pushing native result T. Okay, so we've popped off all those native arguments. We put the result T on. Now it says render or draw texture. The result value of render or draw texture is T. Now it's telling me which ones it wants to pop. Why is it only going up to 5? Okay, so that was probably incredibly boring for all of you watching. I apologize for having to like investigate these problems instead of getting more interesting things done. However, I do think we did get, you know, something nice, relatively nice looking working. We didn't get the data oriented or the data reading working, but that's something I can do off stream and get this looking nice before next time. And then next time we can try to look into some basic interactivity maybe. We'll see how far we get with that, but let me know if you've watched up until this point. Let me know in the comments what you thought about the stream. If you thought it was kind of boring, maybe it should have moved a little bit faster, and whether you think the game development stuff is actually interesting at all, or if you liked looking at the thumbnail rendering stuff we were doing before, because I'm kind of curious about, you know, how people were feeling about this angle we're taking this month. But I'm having fun, at least. At least I'm having fun doing all of this. I don't know how fun it is to see it on stream, but anyway, that's going to be it for today, folks. Thanks so much for watching, and then we should have another stream on next Tuesday. We'll see how things go until then, and until next time, thanks for being here, and keep it creative. We'll see you.